let's proceed to vector data. So we just saw the tiled display, so raster files, which are good for displaying maps that we can interpret with our eyes. But when going to data processing, such as required in navigation, for instance, it is better to work on vector data which convey their semantics that can be extracted and processed by a computer. Vector data are able, but it's not necessary, to include semantics. So for instance, you have semantics in road connections, public transportations, and so on. There are two examples here that we'll see about vector data. One is S3 shapefile format, which is an ugly, in the sense it's not human readable, fragmented binary file, and the OpenStreetMap files, which are provided as JSON or XML, which is easier to use, but it's less compact. So the shape files are a set of files formats defined by S3, which created the format. Each file can only contain one kind of shape, so it can be polygons, multilines, points, and so on, but you cannot put polygons, multilines, and points inside the same file, for instance. You have to separate into one file for each type of shape. Then those shapes are stored as binary strings with an index file which tells you where to access which shape. So it's you have to rely on a library to parse the file. It can be GDAL, for instance. And it does not include semantics, so you can have several lines to define roads, but the connections are not specified in the files, and sometimes, since the coordinates are in floating point values, it's hard to find the connections if your ends of lines are not exactly the same between two parts of roads or between two roads. So it's a bit complicated. On the other hand, the OpenStreetMap files are provided by many servers. For instance, the overpass-api.de, which provides QL language, and it will return XML or JSON files as a result. All of these results are structured the same way. First, you will have nodes, which are defined primarily with their coordinates. Then you will have ways, which are shapes. So the ways are specified by a sequence of nodes identifier, and going from those node identifiers to the nodes, the corresponding nodes and their coordinates, you can draw or use the ways, shapes, and lines. And last, you have relations which put some more semantics and group your ways and nodes together for some amenity purpose or related to the usage. So, being XML or JSON, the OpenStreetMap files are quite human readable. So what's complicated is that you have node references in the ways that you have to go back to the nodes to find the coordinates. It's easy to use, so you get the nodes, which are basically points. You join points together when they are in the same way, and you have the relations which give some information, more information about groups of ways and nodes, as well as other relations. So relations are composite data. And it's easy to parse thanks to the libraries which can read OpenStreetMap files, such like read OSM library or GDAL OGR OSM driver. In each OpenStreetMap file you have node, ways and relations, and each element is one nature only. So nodes have a unique ID, their latitude, their longitude. There is an option to put the elevation, which is the altitude of the point, and a series of tags which provide node semantics. Tags are always as key values representation, with the key being the type of semantics and the value being its value. Ways are also identified with a unique ID. Then the list of nodes, which are listed in the order you have to draw them to keep the geometry correct. And the same than nodes, you have the tags. And last, the relations, which are composite objects, like I said, contain nodes, ways, and relations. So let's take an example with the roads network in OpenStreetMap files. So the nodes will be the road vertices. So these are the points where the road will change its direction. The ways will define the road segments, and the tags would define various data such as speed limit, one-way streets, and so on. And based on these nodes and ways, you can build a graph and provide navigation, which is what is actually performed by applications on your smartphones, OSM and, which stands for OSM Android, and NAV3, which extracts and formats OpenStreetMap data the way it's efficient for navigation. So OSM and might be slow for big paths, while NAV3 is quite performant. So let's look at a sample file of vector data. Okay, this is a file extracted with the Overpass API, so we see that here actually. Let me zoom a bit. Okay. So first, we have nodes here defined. So you see it's the anchor node with its ID. It's unique. There are no pair of nodes over the whole world with the same ID. The latitude of the node and its longitude. All nodes are defined that way. Here we find some nodes with a tag source, which is actually the cadastre with Direction Générale des Impôts, updated on 2009. Well, roads do not change a lot over time, except if you build new. So we have nodes, and so on. So here we have then the second part with the ways. So one way here, it's idea, and then we have 1, 2, 3, 4, 5 node references. So if we look at that, for instance, I think it's the first one. Yes, it's this one. So we have one of the vertex of the way, which is at these coordinates here. So then we have other node references. And here we see in the tags, first one is source with the source of the data again, which is the same. And one is about tag key is building. So it means that this way actually is a building, and it's a special case of building, which is a train station. And we have another one here, another one here, another one here, and the last one here. So, and here we have the name of the train station, which is Belfort. So actually this file is quite small. We extracted the train stations for Belfort. I'm not even sure we have the junction here, maybe only Belfort City. So that's what an OpenStreetMap file looks like.